Number 14, you're supposed to find the equation of the line tangent to the graph of each function at the given point. So here's our function, here's our point. Write that equation, the tangent line, in slope-intercept form. Slope-intercept form is y equals mx plus b. M is the slope, b is the y-intercept. Graph the function and the tangent line. Be sure to label each function, x and y-intercepts, and any minimums or maximums. This function is a parabola because it is a quadratic. Therefore, it only has one critical point. So if we find the derivative, and the first thing we're going to do here is we're going to find the equation of the line tangent. So to do so, we need to find out what the slope is of that tangent line. Derivative means slope. So y prime equals x plus 1 is essentially saying the slope is x plus 1. The reason there's an x in the slope is because the slope is going to vary depending on where we're trying to find our tangent line on our curve. We want to know the specific slope when x is negative 4, putting the negative 4 in from here. So f prime of negative 4 equals negative 4 plus 1. That means that the slope at negative 4 is negative 3. So once again, we have a slope and we have a point. What better way to write the equation than to use point-slope form, which can be used anytime you have a point and a slope. So 3 is our y sub 1, negative 4 is our x sub 1, and m is negative 3, which is our slope. So we plug those numbers in to this formula. Simplify, subtracting a negative 4 is like adding a positive 4. So this is y minus 3 equals, distribute the negative 3, add 3 to both sides. In slope-intercept form, we get y equals negative 3x minus 9. Tangent equation, y equals negative 3x minus 9. So the first part of the instructions, find the equation of the line tangent to the graph of the function at the given point. And the second sentence, write the equation in slope-intercept form. That is finished. Graph the function and the tangent. Well, I can't graph this function unless I know what its critical point is. We once again know it has one critical point because this is a parabola. We know that critical point's a minimum because the leading coefficient is positive. But it's not in the right form for us to know what that is just by looking at it. So to find the critical values, take the derivative, set it equal to 0, and get x by itself. So we get a critical value of x is negative 1. To find the critical point, we take that critical value, negative 1, put it into the original function. If you do so, remember this is y, which is what the original is, not y prime. You're going to get negative 1 squared, which is positive 1, times a half, which is a half, plus a negative 1 minus 1. That's going to be negative 2 plus a half, which is negative 1.5. You're allowed to use your calculator for that. Not because we are drinking weak sauce, just because these problems take so much time. To show your work for that, just add so much more time. We have a critical point of negative 1, negative 1.5. Once again, we know it's a minimum, but we need to show that it is. If we pick some test points here, such as y of -2, it's to the left of -1, and y of 0, that's to the right of -1. Y of -2, using my calculator, I get -5, and y of 0, we get -1. Scratch that, this is not -5, it's also -1. We're comparing those -1s to this -1.5. Both of these are above -1.5. If they're both above, that means that we have a minimum here at -1, -1.5. We knew that all along. We knew this was a parabola that opened up. So nothing that we didn't already know. So what's left to do? We need to find the x-intercepts and the y-intercept. To find the y-intercept, simply replace the x's with 0 in the function. And you get a y-intercept of -1. So far we have this minimum, we have this y-intercept. X-intercept. Replace y with 0. Get x by itself. To do that, we're going to have to factor. It'd be best if this lead coefficient here was not a decimal. If we factor a negative, or pardon me, if we factor a 0.5 to the front, 0.5 divided by 0.5 is 1. 1 divided by 0.5 is 2. -1 divided by 0.5 is 2. We're looking for two numbers that multiply to get -2 and add to get +2. There are no such integers. This doesn't factor. I just spelled does like does. I'll give you a little bit of this. Oh, yeah, there we go. Doesn't factor. So we have to take our tail and tuck it between our legs and use our calculator. If you ask your calculator what these x-intercepts are by graphing this and then hit second calculate 0, you're going to get x-intercepts about -2.7 and 0.7. Hopefully you can appreciate the irony here. We had this original problem which we're supposed to graph without using a calculator. We get all the way down here to the end to find the x-intercepts, and the only method that we currently know how to find the x-intercepts is to graph the original function. That is the definition of irony. So, to graph this, we have a minimum at -1, -1.5, which is down in this region. We have a negative x-intercept and a positive one. So let's say the graph looks like this. Parabola, which is not great the way I drew it. X-intercept of 0.7 and -2.7. Y-intercept of -1. Vertex -1, -1.5. Supposed to also graph their tangent line, y equals -3x minus 9. And it intersects this at -4/3, -4/3. So maybe it looks a little something like this. And remember, a tangent line represents the slope of this curve. So it should look like it's very similar to it. So I'm going to exaggerate this point of intersection here. And that point of intersection, we were told right here, is negative 4, 3. Let's make sure we have everything graphed. Got our parabola, which I don't have it labeled. This is y equals 0.5x squared plus x minus 1. Our tangent line, I also don't have labeled. Shows y equals negative 3x minus 9. On our curve, we have our x-intercepts labeled, our y-intercept, and our minimum. On our tangent line, I don't have the x-intercepts labeled. I don't have the y-intercept labeled. This y-intercept is negative 9. Let me get rid of that point. X-intercept for this tangent line, at this point my work is just a mess. It's a giant glob of messness. X-intercept negative 3. Dunsies. Number 15 is a strange ranger. For 15, the directions say circle whether each graph is continuous or discontinuous. If it's continuous, circle continuous. If it's discontinuous, then decide if it has infinite, jump, or point discontinuity. Circle the appropriate one, then graph each function. So this is odd because there's an absolute value in a rational function. Let's look at a couple different situations. Let's first say that x was 0. If x was 0, this would be 0 cubed divided by 0, which is undefined. Does that mean there's a vertical asymptote, or does that mean there's a hole? Well, let's assume that this was not cubed. Well, let's assume it's cubed. Let's assume there's no absolute value. You could cancel an x from the top and the bottom then. So essentially, there's a hole here because you could cancel an x theoretically, although you can't really cancel an x. You're going to listen to me talking in circles quite a bit on this problem. So we have a hole on this problem at x equals 0. If you cancel that, you'd be left with y equals the absolute value of x squared, kind of. This is fun stuff. If you put 0 then in for x, absolute value of 0 is 0, 0 squared is 0. So hopefully you can see, even though I'm saying things like kind of and yes but not, our hole is at 0, 0. Any fool can see that. So if you don't see it, it means you're not a fool, which is awesome. What if x was greater than 0? So it's a positive number. So I'm going to use a method here that I call the fantasy make-believe method. I'm going to put a positive in for x. To show that, I'm just going to put a little plus x, absolute value cubed divided by positive x. What's the absolute value of positive x? I think you would agree that's a positive x. What's a positive number cubed? That's just going to be a positive number. It's going to be a cube number that's positive. What's a positive divided by a positive? It's a positive. What's x cubed divided by x? Well, it's x squared. So here's what this tells us. If x is bigger than 0, we're supposed to graph y equals x. This is a piecewise function. Graph y equals x squared if x is greater than 0. So we've just shown here. Well, what if x is less than 0? What happens? Well, using the make-believe method of Gnomeville, we put a negative in for x, denoted by a negative x. What's the absolute value of a negative number? Well, it's a positive number. Like before, what's a positive x cubed? Well, it's an x cubed that's positive. If you divide a negative by a positive, or a positive by a negative, I should say, you get a negative. X cubed divided by x is x squared. So here we're getting, this simplifies to y equals negative x squared. So if x is less than 0, we graph y equals negative x squared. So we did this first, did this second, did this third, and we conclude with this. So this is what the graph looks like. Well, not entirely. Plus there's a hole at 0, 0. This is what the graph looks like. From the right of the y-axis, it's a parabola that opens up. From the left, it's a parabola that opens down. So here's how your graph should be. The hole at 0, 0. So here's what a parabola looks like. It opens up, but it says if x is greater than 0, then you just graph the right part. This is y equals negative x squared, which looks like this. But it says here if x is less than 0, that's over here, just graph the left part. So the graph looks like this. Kind of looks like y equals x cubed, but it's going to be a little bit fatter, if you will. It's going to be shrunk vertically compared to that. So is this graph continuous? No, it's discontinuous. What type? Point discontinuity. Number 16. Hopefully you know right now it's discontinuous, and it is infinite discontinuity. This resembles the parent equation y equals 1 over x. This minus 5 translates it to the left 5. So with no work, we know we have a vertical asymptote at x equals negative 5. Just like the parent, we have a horizontal asymptote at y equals 0. And the curve looks like this. It says a y-intercept. To find that y-intercept, simply put 0 in for your x values. You get 1/5. Dunsies. 17. Without graphing, describe the end behavior of each function. To do so, you only need to look at the leading term. The leading term is not the first term, but it's the term that has the biggest exponent. Cubed is the biggest exponent. Therefore, the leading term is negative 6x cubed. From this term, you only look at two details. One, is this positive or negative? This is negative. 2, is this odd or even? It's odd. It's a 3. Can you think of a parent graph that has an odd exponent? I sure can. Y equals x cubed, which looks like this. Notice this is a positive. This says negative. So y equals negative x cubed is the same graph as that, but it's reflected over the x-axis. The end behavior that you can see here from y equals negative x cubed is the same end behavior that you would have from this mess. As x goes left forever, as x goes left, y goes up. Up forever is positive infinity. Here, as x goes right forever, as we go to the right, we're going down. Going down for the y's is negative infinity. (18 and 19). Two things. A, determine whether each graph is continuous. Let's look at that first. This graph is discontinuous. How do we know that? This has a vertical asymptote. You should know that the parent graph for this is y equals 1 over x. Anytime you have not anytime, 99% of the time when you have a variable in the bottom of a fraction, it's going to be discontinuous. 19, is this continuous or discontinuous? You should know that this is the absolute value function, which looks like this. It's continuous. B, state the interval for which each function is increasing or decreasing. A function changes from increasing to decreasing in a couple different places. One, if there's a maximum or minimum. Two, if there are vertical asymptotes. Sure that there are other places as well, but for us, it's basically going to come from one of those two things. So number 18, once again, the parent for this looks like this. You can see here from left to right, it's going down. Here from left to right, it's also going down. If it's an increasing function, state the interval for which the function is increasing. If the function is increasing, that means from left to right it's going up. Decreasing means it's going down. This is going down every place except for this vertical asymptote. So we just have to find it. This -2 translates this graph to the right 2, putting the vertical asymptote at x equals 2. So this graph is increasing, pardon me, nowhere. It's decreasing. When you write the interval, you start from the left and you go to the right. From the left is negative infinity, and it continues to decrease till it gets to 2. Does not include 2. Starts decreasing again right after 2, denoted by right after 2, and it goes forever to the right, infinity. Important to note, state the interval. That's referring to x values. For which the function is increasing or decreasing. That's referring to the y values. Going up is increasing, going down is decreasing. Number 19, we can see here that the parent graph, it's decreasing until it gets to the vertex, and then it's increasing after that. It's at the minimum. Well, where's this vertex? This +7 translates it to the left 7. So -7, 0 is the minimum. So this graph is increasing from -7, not including it, forever to the right. This part of the graph is going up. This part, from going left to right, it's going down. So that's from negative infinity to -7. Triple Spoon's packing plant is developing a new type of can that will contain peaches. The can's a cylinder. If the can has to have a volume of 500 cubic inches, determine the radius, height, and the minimum surface area needed to manufacture the most cost-effective can. If you're going to minimize the surface area, that means you need to find the derivative of the surface area, set it equal to 0, and find its minimum point. Where the, let's say we use x and y's, the x would be the, well, depends on what it is. Could be radius or height. And the y would be the smallest surface area. So let's first draw this can. Can has two dimensions. It has a radius and it has a height. R is radius. H is height. Mentions volume. So V is volume. It mentions surface area. So SA is surface. Area. Also told that the volume needs to be 500 tiny cubes that are 1 inch by 1 inch by 1 inch. So this is simple. We just need a surface area formula. I'm going to make this a bit smaller. Surface area is the area of each surface added together. The top surface, area of the top. The bottom surface, area of the bottom. Area of the lateral surface. Lateral means side, so this is the side. The top and the bottom are circles. To find the area of a circle, it's pi times r squared. The top and the bottom of a cylinder are the same size circle. The lateral. The lateral, it looks like I have a strange shape here, but it's really a rectangle. Has two dimensions. It has a height, and the width would be the circumference of the circle. If you've ever taken a soup label, sliced her down the middle, and then spread it out, it's a rectangle. You wrap it around here and it looks like some kind of a weird shape. But this part up here, once again, that's the width or length of that rectangle. That's circumference of the circle. Circumference is 2 pi r. So all we have to do now is simplify this. Pi r squared and pi r squared is 2 pi r squared. 2 pi r h. Now we just got to find the derivative, which we can't do because there's two variables. So look at the pickle we are in right now. Quite the pickle. Did this first, did this second, I'm going to do this third. Volume of a cylinder. That's a cylinder. It's the area of the base times the height. Told here that the volume is 500 cubic inches. Area of the base, that's a circle. Height, that's an h. If you get h by itself, you get 500 cubic inches divided by pi r squared. We can now replace all these h's here. Now there's only one. With 500 divided by pi r squared. If we simplify this, r divided by r squared, this is going to be r. Pi divided by pi cancels. 2 times 500 is 1,000. Divided by r. I don't want to write divided by r. I want to write r to the negative 1. That way when I find the derivative, which is going to happen right now, I don't have to worry about a fraction. Take the exponent of 2 and multiply it by the coefficient in front. Subtract 1 from the exponent. Take the exponent negative 1, multiply it by the 1,000. Subtract 1 from the exponent. Negative 1 minus 1 is a negative 2. Set the derivative equal to 0. We're just finding critical values here. We were critical values because the directions say minimize surface area. If I rewrite this so that it's 1,000 over r squared, that makes a little bit more sense to me. If I want to get rid of my fraction, I can multiply each term by r squared. So I can go dot r squared, dot r squared, dot r squared. Here the r squareds cancel. Here 0 times r squared is 0. Here we get 4 pi r cubed minus 1,000. Trying to get r by itself, if I divide both sides by 1,000, pardon me, if I add 1,000 to both sides, divide both sides by 4 pi, 1,000 divided by 4 is 250. 250 divided by pi is irrational. I wrote this wrong, this should be r cubed. And I cube root both sides. Put that into my handiest of dandiest calculator. It's going to come out to be 4.3 approximately. The radius of this can is 4.3 inches. So what's there to do next? We got to find the height. Up here we had the height was 500 divided by pi r squared. So that's 500 divided by pi times 4.3 squared. It's going to be 8.6 for the height, inches. So we got the height, we got the radius. How do we know this is going to be a minimum the surface area? We could check, we could pick test points, put it into the original function, make sure this is the lowest point. If you do that, you'll find out that it is. I'm not going to trick you, telling you it's a minimum surface area. Trust me on that. Then we got to find the surface area. If we take the surface area formula and plug in 4.3 in for the r values. Just checking out my formula and make sure I'm putting the right numbers in. This ends up being approximately 348.7 cubic inches. So radius 4.3 inches, height 8.6 inches, surface area 348.7 square inches.